Good evening, students. So, myself, Richa Patil, and I am your chemistry teacher. So, till today, we have met in different sessions. Okay, so we have met during our CET sessions and NEET session. So, I can see some of our NEET students here. So, so as we know, till now we have discussed from CET point of view and NEET point of view. Okay, so now we have come up to help you for your boards. Okay, so as your boards is approaching, right? So from March, tentatively March first week, you'll be having your board exams. So as you are preparing, so it is our responsibility also to help you all, okay, to score some good marks. So here what we are going to do in these sessions, so here we are going to concentrate on the important questions. Okay, so which are the important questions which are asked repeatedly. So there are some of the important questions in each lessons. Okay, so as you know, so the lessons are reduced. Okay, so you have 10 chapters. So we are going to go through the blueprint first. Okay. So this is a blueprint which is released by PU board. Okay. So this is a blueprint for PUC 2. Okay, PUC second year. So chemistry. So this is the question paper pattern. So you'll be having a part A, okay, to part E. So part A, it consists of MCQs question, right? So the pattern, exam pattern has been changed. So till last year, there were no MCQs and fill in the blanks. So 1 mark questions, then 2 marks, 3 marks, followed by 5 marks. But they have include MCQs and fill in the blanks so that you go thoroughly to the NCRT. Okay. So the main, what is the main motto behind keeping MCQs and fill in the blanks is to study your textbook, okay, thoroughly, so that you can score well. Okay. So part A, okay, so part A consists of your MCQs. So the number of questions asked will be 15. Okay, so the number of questions asked will be 15. So each MCQ will be for 1 mark. So 15 marks. Okay, so there are some, so it is given. So from which chapter the MCQs will be coming, from which chapter the fill in the blanks will be coming. Okay, so according to blueprint, we are going to see. So part A, fill in the blanks, it is for 5 marks. So 5 fill in the blanks for 5 marks. Then part B, it consists of short answers. Okay, short answers for 2 marks. So 2 marks, so 6 questions are given. Out of 6, you are going to answer 3. Okay, so 6. So the marks allotted will be 6. Next, your part C. Okay, so part C, it is exclusively from inorganic chemistry. Okay, so there are some chapters which are exclusively from inorganic chemistry. So from those section only, the questions will be asked. Okay, so that will be for 3 marks. So the number of questions asked will be 6. Out of 6, you have to answer 3. Okay, so the marks, so the total marks, this will be 9. So you can score from here 9. So there will be 3 more options. So from the 6, you have to select any 3. Next part C, short answers for again 3 marks. Physical, from this part will be from physical chemistry. Okay, from the exclusively from the physical chemistry part. So the number of questions asked will be 4. Okay, you have to answer 2 questions. Okay, so the marks you will get is 6. Okay, so total questions will be 4. 4 questions will be asked. Okay, but you are going to write 2. So the allotted marks is 6. Next is part D, long answers. Okay, which are for 5 marks. So this will be from theory part. Okay, theory part and organic. So this will be organic part D. So the number of questions asked will be 7. So 7 questions will be given. So out of 7, you can answer any 4. Okay. So the allotted marks is 35. But if you write 4, so here you can score 20 marks. Okay. Then part E is again short answers. So here it is numerical problems. So you will get your numerical problems. Okay. Problems from your physical chemistry. So part E is concentrated completely on your physical chemistry. So the number of questions, so the problems will be 6. Okay, out of 6, you can answer any 3. So the marks allotted will be 18. You can fetch 9 marks here after solving correct 3 questions. Okay. So the whole question paper is set for 115 marks. Okay, so the total number of question asked will be 49. So out of 49, you are supposed to write 35 questions. Okay, so total marks will be, total questions asked is 49. Okay, and you are supposed to answer 35. So the total marks is 115. So the total, so there are too many options. Okay, so you have to write for 70 marks. Okay, so you can write this down. You can write. Okay, you can write this points. So you will get a idea. So if you don't know how the exam pattern will be, how your chemistry paper will be, you can write it down. Okay, so you are supposed to take a pen and paper. Okay, and you need to write some important notes so that it will be helpful for you. So simply if you sit in front of the screen will not help you. Okay, so you can just note down some important things which are told, so that at the last moment, if you open that, it will help you. Okay, so here, so this is the pattern. Okay, so this is the blueprint. So this weightage is for so this will not go. So now the the total, so chapter wise. Okay, so this is a chapter wise weightage. Okay, so this is the chapter wise weightage. So as you know, okay, 49 questions. Okay, so overall 49 questions will be given. You have to answer only 35 questions. Okay, so which are the important chapters? So now there are 10 chapters. So previously you had 16 chapters, right? So the 6 chapters have been deleted. So the number of marks allotted for each chapter has been increased now. Okay. So solution chapter, so the number of, okay, so the number of marks allotted is 13. So for solutions, the number of marks allotted is 13. So how the 13 marks are allotted from like 1 mark, 2 mark. Okay, so 1 mark, 1 question is asked. Okay, so two questions are asked. Okay, so 1 mark, 2 questions are asked. Then 2 mark, 1 question is asked. Okay, from applicative type. Then 3 marks, 2 questions are asked. Okay, one is your theory based question, and 2 more are your problems. Okay, based on the problem. So from solution chapter, this is the pattern. Okay, this is the weightage. Next is electrochemistry. So electrochemistry, the number of marks allotted is 14 marks. How many marks are allotted? It is 14 marks. Okay, so here 1 mark question asked are 2. Okay, 2 1 mark question is asked. One is a simple question. Okay, another is the applicative type. Okay, another is applicative type. Then your 2 marks question is not asked. Okay, 2 mark question is not given. 3 marks question, one is theory based. Okay, 2 are theory based questions. 3 marks question, 2 theory based question is asked, and 1 problem. Okay, 2 problems are there from electrochemistry. So this is the weightage. So 1 mark, 1 mark, 2 questions, 3 marks, 2 theory based questions, and 2 problems. Okay, numerical problems. Next, physical chemistry chapter is chemical kinetics, which is the next chapter. It is chemical kinetics. So the number of marks allotted is 13 marks. Okay, so 1 mark questions, two 1 mark questions are asked. Okay, so here 2 1 mark questions are asked. Then no 2 marks question, 3 marks, one theory based question. Okay, so 1 mark 2 questions, then 2 marks 1 question is there, and 3 marks 1 theory based question, and 2 numerical problems. Okay, 2 numerical problems. So this is the, so your physical chemistry, there are 3 chapters: solution, electrochemistry, and chemical kinetics. So from this only you will get 6 problems, numerical problems from this 3 chapters. Okay, so this is the weightage from your physical chemistry. Next is inorganic chemistry. So inorganic chemistry, there are 2 chapters. The first is D and F block elements. The weightage for this chapter is 11 marks. Okay, so the weightage for this chapter is 11 marks. Then next is, so how is the weightage given? So 1 mark, 2 questions are there. Okay, 1 mark, 2 questions are there. Then 3 marks, 3 marks, three questions are there. Okay, 3 marks, 3 questions are there. So 1 mark, 2 questions, and 3 marks, 3 questions. Okay, so there are no 2 marks question from this section. Then coordination compounds, the number of marks allotted for this chapter is 12 marks. Okay, so 1 mark, 1 mark is okay, 1 mark 1 question, then 2 mark 1 question, and 3 marks 3 questions. Okay, 3 marks 3 questions. So this is the weightage from your coordination compound. So these are the 2 chapters which come under inorganic chemistry. Next is organic chemistry. So the number of lessons in this organic chemistry, there are 5. Okay, so there are 5 lessons. So the first is haloalkanes and haloarenes. Okay, haloalkanes and haloarenes. So the number of marks is 9. The number of marks given is 9. So 1 mark question, there are 2 1 mark questions asked. Then 2 marks 1 question, and long answer. Okay, that is for 5 marks. 1 question is asked. Okay. So long answer, that is for 5. So the part E section, as you remember, we have seen in the blueprint. So part E section. So okay, so 5 marks question, it is not directly asked for 5 marks. It will be divided into 3 plus 2 again. Okay, it will be divided as 3 plus 2. Next is alcohol, phenols, and ethers. Next is what? Alcohol, phenols, and ethers. So alcohol, phenols, and ethers, the number of marks allotted is 12 marks. Then the MCQs asked, number of MCQs asked are 2. Okay, 1 mark, 2 questions. Then 3 marks, 2 questions, 3 marks, not 3 marks. There are no 3 marks. So directly 5 marks, 2 questions are there. Okay, 5 marks, 2 questions. So 1 marks, 2 question, and 5 mark, 2 questions from this particular alcohol, phenols, and ethers. Next is aldehyde, ketones, and carboxylic acid. Okay, next is aldehyde, ketones, and carboxylic acid. The number of marks allotted is 14. Okay, then 1 mark questions, there are 2 1 mark questions asked are 2, then 2 marks 1, and long answers 1. Sorry, 2. Okay. So there are 2 long answers. Okay. So that will be divided into 3 plus 2 again. So this is aldehyde, ketones, and carboxylic acid. Next is amines. So amines, the chapter is allotted for 8 marks. So 1 mark question, 3 questions are coming from this chapter. Okay. Uh, 3 questions are coming from this chapter. Then there are no 2 marks question. There is one 5 marks long answer. Okay, in the part E. So organic chemistry, as you know, in the part E, you will be having directly the 5 mark questions. Okay. Then next chapter is biomolecules. The number of marks allotted will be 9. Okay. So 1 mark questions, the number of question asked will be 2. So 1 mark question, 2 questions will come. Then 2 marks, 1 question. And your long answer will be for 5 marks, 1 question you will get. Okay. So, so this is the weightage, okay, and the blueprint given by PU board for this academic year 23-24. Okay, so this is your chemistry blueprint. So how do we stress now? So as the number of lessons are reduced, okay, as the number of lessons are reduced, you can see the weightage has increased. Okay, so to score well, okay, to score well, what you can do first, you have to concentrate on the more weighted chapters. Okay, so which are the more weighted chapters? So from the organic chemistry, you can see aldehyde, ketones, and carboxylic acid. Okay, then alcohol, phenols, and ethers. Then you can see these 3 from physical chapter. Okay, so these are some of the important chapters you can focus. Okay, so all the chapters are important as the number of as the lessons are deleted. Okay, so the weightage has increased, but you can concentrate on these many lessons. Okay, so this was the blueprint and the weightage for this academic year. So what we are going to do in these sessions? So we are going to concentrate on each chapter, okay, and we are going to stress on the important questions. So today we are going to start with the first chapter, that is solutions. Okay, so what we are going to start today? We are going to start with the first chapter, that is solutions. Yes. So what are solutions? Yes, what are solutions? So we can have an interaction. Yes, the students from YouTube as well as from the Zoom, you can interact with me by dropping a message in your chat box. Okay, so I can see your responses there. So I want, so we will have an interaction. Okay, so there shouldn't be a one-side interaction. So the interaction should be from both the side. Okay, so the first so the first chapter we are going to start was solution. Okay, so as we have seen, the total marks allotted is how much? 13 marks. So 1 marks, 2 questions. Okay, then 2 marks, one question, and 3 marks, 3 questions. So out of 3 questions, 2 are numerical problems and 1 is a theory-based question. So total, it will be for 13 marks. Okay. So we are going to see the MCQs first. Okay, so we are going to start with the MCQs. So these are some of the important questions. Okay. So I have tried to, so what we are going to do as we are solving the questions, we are going to touch the concepts. Okay, we are going to see the concepts. So the first question here is solution of hydrogen in palladium or ornamental gold containing copper is an example for. So you can, so meanwhile, as I am reading out, okay, I want the answers from your, okay, as well as you can note it down. Yes. So the solution of hydrogen in palladium ornamental gold containing copper is an example for. So there are four options: A, solid solution, then B, liquid solution, C, gaseous solution, D, homogeneous solution. Yes, I can see the responses from Zoom students, YouTube students. Can you see the screen? Yes, please chat in the chat box. Yes. Yes, the answer is A. Okay, solid solution. Good. So what are these solutions? Yes, the answer is right. Now we'll have, okay, so what are solutions? So solution is what? It is a homogeneous mixture. Okay, what is a homogeneous mixture? So solution are homogeneous mixture of two or more components. Okay, it is a homogeneous mixture of two or more components. Now, what is this homogeneous mixture? Yes, what is this homogeneous mixture? So in homogeneous mixture, the composition is uniform. Okay, it is uniform throughout the mixture. So it is uniformly distributed. Okay, suppose I take a sugar solution. I take a sugar solution. Okay, now so what I'm going to do, take a beaker. Okay, take a beaker, add, take water. Okay, in this water, add some sugar. Add some sugar and stir it well. Okay, and stir it well. Will your sugar remain aside and water will be aside? No, right? The sugar and water will be mixed. Okay, it will be mixed thoroughly. So it is called as a uniform composition. So it will be uniform throughout the mixture. Okay, so homogeneous mixture. So what are these solutions? Solutions are homogeneous mixture of two or more components. Now, what is this sugar in and water? Okay, so solutions, okay, so they are made up of solute and solvent. It is made up of what? Solute and solvent. Now, what is solute in this? Our solute is sugar. Okay, sugar is our solute and water is the solvent. Okay, sugar is the solute and water is the solvent. Now, so there are types of these solutions. Okay, so this solution is clear. What is solution? What is solute? Okay, what is solvent? So always this solute will be in small amount. Okay, solute will be present in small amount and solvent will be present in more amount. Okay, remember these things. So there are some types of solution. Okay, what are the types of solutions? So the first is gaseous solution. Okay, gaseous solution. Second is liquid solution. And the third is solid solution. Okay, so third is solid solution. Now gaseous solution means what? Both the solute and solvent are gaseous in state. Okay, liquid, what is a liquid solution? Here, both the solute and solvent are liquid in state. Okay, they are in liquid in state. Then solid solutions are those in which the solute and solvent, they are solid in state. Now you know what is solid, liquid and gaseous, right? Okay. So now here, what they have asked, solution of hydrogen in palladium. Okay. Solution of hydrogen in palladium. So what is palladium? So palladium is a solid. Okay. And your hydrogen. Okay. So the solution of hydrogen in palladium or ornamental gold. So the gold which we use, okay, the gold which we use here. So what it is, gold? So gold is a solid. So gold is a solid, and the copper, okay, it is a solid. So this is a example of what? It is an example of solid solution. Okay, so this is a example of solid solution. Fine. Next is second question. Camphor dissolved in nitrogen gas is an example for the solution of the type. Yes. A, liquid in liquid. B, solid in liquid. C, solid in solid. D, solid in gas. Camphor. What is camphor? What do you call camphor as? Karpura. Right. So, in the nitrogen gas. So, camphor. What is camphor? Camphor is solid. Okay, what is the state of camphor? It is solid. And nitrogen gas is what? Nitrogen is a gas. Okay, nitrogen is a gas. So, solid is in gas. So, this is an example of solid in gas. So, which is the correct answer? Yes. Good. So, most of you have answered it right. It is D option. Good. Yes. So, I can see good responses from all of them. Harshita, Lakshmi, Tasrifa, Netravati, Suhas, Ilsa. Yes, I can see good responses. Here also I can see in YouTube. Good. Okay. So we'll go for the next question. In which mode of expression the concentration of solution remains independent of temperature? Okay, what do you mean by independent? It does not depend. Okay, so in which mode of expression? So there are some concentration terms. Okay, there are some concentration of the solutions can be expressed in. Okay, so it remains independent of temperature. So which among the concentration term, okay, it is independent. It is not dependent on temperature. Independent. A, molarity. B, molality. C, volume percentage. D, mass by volume percentage. Yes. What is the answer? Yes. Most of you have answered it as yes. Pawan, Sindhu, Suhas. Yes, molality. Here also Suma Shivamurthy, Abdul Rahim, Shreya Kulkarni. Yes, the answer is right, Prakash. It is molality. Okay, now we'll see how it is. Okay, so we are going to see each expression term. Okay, now what do you mean by molarity? So molarity, what do you mean by molarity? What is molarity? So molarity is number of moles of solute, okay, dissolved in per liter of solution. Okay, so volume of solution is taken in liter. Okay, so number of moles of solute dissolved in 1 liter of solution. 1 liter of solution is nothing but 1000 ml. Okay, so number of moles of solute divided by volume of solution in liter. Now, molarity. Okay, so molarity is inversely proportional to volume. Okay, so molarity is inversely proportional to volume, and volume is directly proportional to temperature. So we can relate volume and temperature, right? So as molarity varies, as molarity, if you change molarity, if you increase molarity, okay, if you increase the temperature, molarity will decrease. Okay, if you increase the temperature, what will happen to molarity? Molarity will decrease. If you decrease the temperature, what will happen? If you decrease the temperature, molarity will increase. Okay, so it is inversely proportional. So it will vary. Okay, it will vary. How it will vary? So molarity will vary indirectly with temperature. So inversely. So it is dependent. So molarity is dependent. So this answer is typed out. Okay. Now, next we'll see is volume percentage. What do you mean by volume percentage now? What do you mean by volume percentage? So volume percentage, volume of solute divided by volume of solution in 200. Okay, volume of solute divided by volume of solution into 100, that is V by V. Okay, V by V, volume. Okay, volume of solute divided by volume of solution into 100. So this is about volume. That is, what do you mean? Means 30. If it is 30% volume by V by V, means 30 ml of solute. Okay, 30 ml of solute is dissolved in 100 ml of solution. Okay, it is dissolved in 100 ml of solution. Now volume percentage, what you can see here. So volume percentage, what will happen? So here also volume is there. Okay, so volume percentage is inversely proportional to volume. So which in turn is directly, so volume is directly proportional to your temperature. So if volume percentage, so if you increase the temperature, what will happen to volume percentage? Volume percentage will decrease, right? Why it is inversely proportional? What do you mean by inversely proportional? Okay, so as you increase the temperature, your volume percentage will decrease. It is dependent. Okay, so as so volume is temperature dependent. So volume is temperature dependent, and it changes. Okay, it changes with change in temperature. So as temperature increases, volume percentage will decreases. So this is also a dependent quantity. Okay, it is a dependent quantity. So next is mass by volume percentage. Next is mass by volume percentage. What do you mean by mass by volume percentage? W by V. Okay, W by V. Now, how is this W by V given as? Yes. So volume, W by V. Okay. So weight of solute divided by volume of solution, So if you take mass by volume percentage, if you take mass by mass by volume percentage, okay. So that is mass by volume percentage. So mass by volume percentage. Now again here it is, volume is there in the denominator, right? So volume, so mass by volume percentage is inversely proportional to volume. It is inversely proportional to volume, and volume is temperature dependent. So it is volume is directly proportional to temperature. So here you are again, as you increase the temperature, what will happen to mass by volume percentage? It is decreasing. So this is also temperature dependent. Okay, so this is also temperature dependent. Now our next, this is what? Molality. Now what is molality? Yes, what is molality? So we are seeing the definitions also, right? So we are seeing the definitions of these concentration terms also. So what is molality? Molality is what? Molality is number of moles of solute, number of moles of solute divided by mass of solvent in kg, mass of solvent in kg, right? So number of moles of solute divided by mass of solvent in kg, right? So how it is given? So molality, okay, it is given as small m. So molality, so number of moles of solute and mass of the solvent, okay, it will, so always the mass and the mole, okay, it do not vary with temperature, okay, mass is a, so it is does not depend. So molality of any solution, it does not depend on temperature, because mole number of moles of solute also does not depend on temperature, and your mass also does not depend on temperature. So molality, it does not depend on temperature because it involves mass, so it is independent of temperature. Understood? Yes, good. Noor, Sidra, yes, good. Priyanka, yes. Okay, good. So you know the definition well. So do not get confused between molarity and molality. What is molarity? Number of moles of solute dissolved in 1 liter of solution. And what do you mean by molality? Molality is number of moles of solute uh, in dissolved, that is dissolved in 1 kg of solvent. Okay, dissolved in 1 kg of solvent. Understood? I hope this is clear. Yes, are you getting me? Yes, is it clear? So we till now we have solved 3 questions. So this is this way good for you? So as we are touching the questions, so meanwhile I'll be explaining the concept. Is it okay for you all? Yes, is it okay? Is it understanding? Am I fast? Am I slow? So yes. So we'll, okay, fine. So we'll go with this flow only. Okay, if you do not understand anything, if you want me to explain anything, please drop the message in the chat box. I'm reading your messages. Okay, so I'll explain you. If you want me to change the pattern, I can do it. Okay. So this is the third question which we have solved. So next we are going to see the fourth question, that is unit of molarity is. So what is the unit of molarity? A, mole per liter. B, mole per kg. C, kg per mole. And D, millimole per gram. Okay, so there are many answers now. Yes, good. Netravati, Sakib, Mangal, Redmi, Noor, Sidra, Pavan, Sita, Suhas, Anvita, Ilsa, Jyoti. Yes, good. Okay. Yes, you're also Sonu, Siddhamma, Ojappa. Yes, good. So, yes, Vinushree, Preeti. Yes, your answers are right. It is mole per liter. So now we'll see. So we have seen what is molarity. Yes. So what is molarity? Number of moles of solute dissolved in 1 liter of solution. So volume of solution in liter. Okay, in liter. So number of moles of solute dissolved in 1 liter of solution. So what is number of moles of solute? Number of moles of solute, it is given by mole. Okay, so the unit used is mole. Volume of solution in liter, so it will be capital L. So mole per, okay, so mole per, okay, so this is the answer, A. Good. Yes. Prakash, Vishal, Sonu, Shreya. Yes, good. Okay. So we'll go for the next question. Value of Henry's constant Kh. A increases with increase in temperature. B decreases with increase in temperature. C does not depend on temperature. D first increases, then decreases. Yes, what will be the answer? Vinushri, Lakshmi, Pavan, Netravati, Noor Sidra, Tasrifa, Jyoti. Yes, your answers are right. Priyanka, Anvita, Sita. Yes, the answers are right. Harshita. Good. Okay. So, what is Henry's constant now? What is Henry's constant? Henry's law. Yes. First, we'll see what is Henry's law. So, partial pressure of a gas, okay, partial pressure of a gas is directly proportional to its mole fraction. So, this is Henry's law. Am I right? Yes. So, what is Henry's law? Partial pressure of the gas is directly proportional to mole fraction, or what is the other definition? Yes, one more definition. At constant temperature. Okay. At constant temperature, the amount of gas that is dissolved in a liquid. Okay. The amount of gas that is dissolved in a liquid is exactly proportional to partial pressure of that gas above the liquid, above the liquid. Okay, so this is the definition. So at constant temperature, the amount of gas that is dissolved in a liquid is exactly proportional to partial pressure of that gas above the liquid at constant temperature. So this is the mathematical expression of Henry's law. That is, partial pressure is directly proportional to its mole fraction, which is so when you remove this proportionality sign, okay, so if you remove this proportionality sign, so if you want to remove this proportionality sign, we have to introduce a constant, that is Henry's constant. Okay, so when we remove this proportionality sign, we are introducing a constant which is a Henry's constant. Okay, so Henry's constant, I take it this side, so it will be partial pressure okay, divided by the mole fraction. So what will happen here? Only nature of the gas or liquid. Okay. So what will happen? Value of KH. So what will happen? The value of KH will increase. So how the value of KH will increase and temperature increases. Okay. So value of KH increases with the increasing temperature. Okay. So this is about your Henry's constant. So value of Henry's constant. So as you increase the temperature, okay, so the value of KH increases with the increase in temperature, okay, and vice versa. So partial pressure, okay. So This is about your Henry's constant. Next is molality. Okay, so next question is molality is A, N by V in liters, B, N by W in kg, C, N by V in liters, and D, none. Okay, Pavan, Sita, Swati, Ilsa, Nitravati, Priyanka, Noor Sidra, Suhas. Yes, the answer is right. Okay. So molality, what is molality? Molality is number of moles of solute dissolved in 1 kg of solvent. Okay. So the mass of the solvent is in kg. Mass of the solvent is in kg. So number of moles of solute is given as mole. Okay. And mass of the kg, so it will be kg. Now moles, it is represented by small n, and kg is nothing but it is your weight, right? So it is n by w, b. Okay, n by w, b is the answer. Understood? Yes. Okay, so we'll go for the next question. Low concentration of oxygen in the blood and tissues of people living at high altitude is due to. So as you go higher, now people go on mountains. Okay. So many of you might have visited mountains. Yes. So when you are here, okay, and when you go to the mountains, how you feel? Yes, the supply of oxygen will be same. Will it be the same? So what will affect? Yes, what will affect? So so what are the options? Just we'll see the options first. A, low temperature. B, low atmospheric pressure. C, high atmospheric pressure. D, both low temperature and high atmospheric pressure. So low concentration of oxygen in blood. Okay. Now you know. So for the supply of this, what the blood to pass in our body, okay, there should be continuous supply of oxygen. If that oxygen supply is reduced, okay, what will happen? What will happen? Yes, you will feel suffocated, right? So what will happen? Yes, so low temperature as you go. Okay, so so people when they go at a higher altitude, okay, when they go at a higher altitude, maybe when they are hiking on their they are hiking on the mountains. Okay, so what they feel? So for oxygen is nothing but a gas, right? What is oxygen? Oxygen is a gas. So low temperature of oxygen in blood and tissues. Okay, it refers to what? It refers to lower solubility of oxygen. Means the amount of oxygen soluble in the body will be lower. Okay, because because as the concentration of oxygen is less in the blood and tissues, it refers to that oxygen as it is a gas. Okay, it has to dissolve in blood. Okay, it has to dissolve in blood and in tissues. Okay, when there is higher concentration. So when the oxygen concentration is higher, what will happen? The solubility of oxygen will be also more. Okay, so which is a gas. Now when you go at a higher altitude, what we experience lower atmospheric pressure. Okay, as you go at a higher altitude, what we experience will experience very low atmospheric pressure. Okay, as we go higher and higher. So as we climb higher and higher, the oxygen supply goes on reducing. Okay, so as you go higher altitude means lower atmospheric pressure. Now, according to Henry's constant, so this is the application part of Henry's constant. So remember, lower concentration means what? Lower concentration of oxygen in the blood and tissues of people who are living at higher altitude. It is due to low atmospheric pressure. Okay, option B, low atmospheric pressure. Fine. Now, here, so it is due to what? It is due to low atmospheric pressure. Now, according to Henry's constant, we know that partial vapor pressure is it is inversely proportional to its mole fraction. So when we remove this proportionality sign, we will introduce a constant, that is Henry's constant. Okay, this is your chi. This is mole fraction, fraction. Okay, so solubility of oxygen in blood is very less. Why? Because of low atmospheric pressure. So your this, as you know, partial vapor pressure is directly proportional to your mole fraction. Okay, so atmospheric pressure is less, so mole fraction also will be less. So as your atmospheric pressure is less, your mole fraction is also less. So remember that as the people who are going at a higher altitude, okay, so their concentration of oxygen will be reduced. Why? Because of lower atmospheric pressure. Okay, so the next question, to avoid the medical conditions, okay, bent tanks of scuba divers are filled with air diluted with. So scuba diving, okay, the people who are doing scuba diving, okay, they are this, okay, the what do you say, the tank of which they are carrying behind, it is diluted with what? A, argon, B, nitrogen, C, helium, or D, carbon dioxide. Helium, yes. Yes, Jyoti, Kasim, Priyanka. Yes, good. Okay, so it is option number C. It is helium. Okay, it is helium. Good. So these are the these two questions are the applications. Okay, these are the applications of Henry's law. Next question. What happens when blood cells are placed in pure water? Okay, what happens when you place blood cells in pure water? A, the fluid in blood cells rapidly moves into water. B, the water molecules rapidly move into blood cells. C, the blood cells dissolve in water. And D, no change takes place. Yes? Yes, YouTube students. What is the answer? What happens when blood cells are placed in pure water? Okay, so many have given different answers. Okay, so we'll see now. Okay. Yes. So this is a question related to osmosis. Okay. So when blood cells are placed in water, okay. So why it is, so when blood cells are placed in water, it is due to osmosis. Now what is osmosis? Yes, osmosis is the phenomena in which the movement of solvent, okay, there is a movement of solvent from higher concentration to lower concentration. So this is the osmosis. So when blood cells are placed in pure water, it is due to the phenomena called as osmosis. What is osmosis? It is the movement of solvent from higher concentration to lower concentration. Okay. So what will happen? Due to osmosis, what will happen? The water molecules, okay? Water molecules will move into the blood cells. Okay, the water molecules will move into the blood cells. As a result, what will happen? The blood cell will swell and even it can burst. Okay, so if you consider a water, okay, so this is a blood cells. So the water molecule, when they are passing, so from a higher concentration to lower concentration, what will happen? The solvent molecule, as it is flowing into the blood cell, what will happen? The water molecules will move rapidly, okay, into the blood cell. Why? Because it is due to osmosis. And what is osmosis? It is the movement of solvent molecules from higher concentration to lower concentration. Is it clear? Yes. So due to osmosis, what is happening? As the water molecules, as it is a solvent, it will move from higher concentration to the lower concentration. So the water molecules will move into the blood cell. As a result, these blood cells may swell. Okay, there will be swelling, or even they may burst. Okay, may even burst. So it is due to osmosis. So the water molecules will rapidly move into the blood cells. Okay, so the other options are, so this is a theory based question. Okay, so B is your correct answer. Okay, so last question, one more question and we'll stop. Okay, so 10th one, at a given temperature, osmotic pressure of a concentrated solution of a substance is A, higher than that at a dilute solution, B, lower than that of dilute solution, C is same as that of dilute solution, and D, cannot be prepared with osmotic pressure of dilute solution. Yes, at a given temperature, osmotic pressure of a concentrated solution is. What is osmosis? Just now we see, so what is osmosis? Osmosis is what? It is the movement, it is a phenomena wherein the movement of solvent molecules takes place from higher concentration to lower concentration. How is osmosis given as? Pi is equals to CRT. Okay, what is pi? Pi is your, so you give it as pi. C is what? C is your concentration of solution. Okay, C is concentration of solution. What is R? R is the gas constant and T is the absolute temperature. Okay, concentration can also be given as what? Concentration can also be given as what? Concentration is given as number of moles. Okay, number of moles divided by volume of solution. So I can write it as C is equals to N by VRT. Yes, I can write like this. So concentration of solution is, as the concentration of solution increases, number of moles also will increase, right? Is it right? Yes. So what did I say? Pi is equals to CRT. So one more time I'll explain. Pi is equals to CRT. What is C? C is the concentration of solution. R is what? R is the gas constant and T is the absolute temperature. Concentration can also be expressed as, what is concentration? Concentration is nothing but number of moles of solute dissolved in volume of solution, which is given as, number of moles is given as small n and volume is given as capital V. Okay, and RT. Okay, this RT. Okay, now as you increase the concentration, of solution, so number of moles, number of ions also will increase. Okay. Now to this concentrated solution, okay, now to this concentrated solution, if we add water, okay, now you have prepared a tea for one person. Now suddenly five more guests have appeared in your house. Okay, instead of preparing four cups more, you are adding water to that tea only. What will happen to the concentration of that tea? Will it be the same or it will be diluted? Yes, if we add the water to the tea, what will happen? The concentration will be diluted, right? The concentration of the tea will be diluted. So if we add water what will happen if we add water to the concentrated solution? What will happen? It will be diluted, right? So if we add water to the concentrated solution, what will happen to number of ions? So number of ions will decrease. Number of ions will decrease. What will happen? Number of ions will decrease. So remember this. So as concentration increases, number of moles increases. So to the concentrated solution, if we add water, then number of ions will decrease. Okay, number of ions will decrease. Now, osmotic pressure. Okay, now osmotic pressure is what? What is this osmosis? Osmosis, it is a colligative property, right? Osmotic pressure, it is a colligative property. So it is a colligative property, right? Now, what is this colligative property? Colligative property means what? It is directly proportional to, it depends on what? It depends on number of solute particles. It depends on number of solute particles. Okay. So osmotic pressure of a concentrated solution will be higher than that of dilute solution. Okay. So option number A. Is it right? Did you understood? Yes. I'll explain it once more. Okay. So it will be A answer. So what is osmosis? So it is a phenomena, okay, the movement of, so how it is given as, it is pi is equals to CRT, where C is the concentration of solution. Concentration can be expressed as number of moles divided by volume. Okay, if the concentration of solution increases, the number of ions also increases. To the same concentrated solution, if we add water, what will happen to number of ions? The number of ions will decrease. If we add water to the concentrated solution, the number of ions will decrease. Okay. So as we know that osmotic pressure is a colligative property and it depends on the number of solute particles. So if a more concentrated solution, more will be ions. If less concentrated solution, less will be the ions. So for higher osmotic pressure of the concentrated solution, okay, so it will be higher. Okay, so osmotic pressure for a concentrated solution will be higher than that of your dilute solution. Is it clear? Yes. Is it clear? Yes. Okay. So these were the questions. Okay. So related. Okay. So relative. We have discussed the concepts also. So we have left with some more MCQs questions. Then we'll be solving fill in the blanks and followed by 2 marks, 3 marks. Okay. So any doubts regarding today's session? Yes. Any doubts you can ask me. Yes, YouTube students. Any doubts? Osmotic pressure is a colligative property. Okay, osmotic pressure is a colligative property. What is colligative property? Colligative property, it is depends on the number of solute particles. Okay, you know that osmotic pressure is a colligative solute particles. If the concentration is higher, the number of ions will be higher. If the concentration is lower, number of ions will be less, right? So osmotic pressure of concentrated solution will be higher and osmotic pressure of dilute solution will be lower. Why? Because it is depending on the number of ions. Is it clear? Yes. Yes, I'll be, so as we are solving the numericals, okay, so that time I'll be revising the formulas. Okay then, so it was good interacting with you all students. Yes, I hope the today's session is clear. So I enjoyed it. I hope you have also enjoyed it. Yes. So we'll stop the session here. So we'll meet in the next class. Thank you. Have a good day.